Unit 2B, Lesson 1. The one standard we're going to talk about in this lesson: use geometric shapes, their measures, and their properties to describe objects. For example, modeling a tree trunk or a human torso as a cylinder. First, we're going to review some common two-dimensional shapes and the formulas for the areas of those shapes. If we have a rectangle, we have the length and the width. To find the area, we multiply those two values. So area is equal to length times width. For a circle, we need to know what the radius is. The area is equal to pi times the radius squared. For the sector of a circle, we need to know the angle theta and the radius. So the area is equal to theta divided by 360 degrees times pi r squared. Area for a triangle, 1/2 times the base times the height. For a trapezium, we think of this as a trapezoid, so you can just, if you write this in your notes, just change this to a trapezoid. The area is equal to 1/2 times the quantity of a plus b times h. For a parallelogram, area is equal to base times height. For a kite, area is equal to 1/2 times x times y. And for a rhombus, area is equal to 1/2 times x times y. For the trapezoid, kite, and rhombus, we can rewrite those formulas a little bit. Make sure to ask me about that in class, and we'll discuss that a little more in depth when talking about the bases and diagonals for the kite and rhombus. Next, we're going to discuss some common three-dimensional shapes and the formulas for the volume and the surface area for those shapes. The first one is a cuboid. Normally, we would call this a rectangular prism. The formula for the volume is length times the base times the height. The total surface area is 2 times the length times the height plus 2 times the base times the height plus 2 times the length times the base. Next is a cube. The volume formula is a cubed. A represents the length of a side. Often you'll have an S for the variable rather than A representing the length of that side. For the total surface area, it's 6 times a squared. Next is a cylinder. For the volume, it's pi r squared times h. For the total surface area, is 2 pi r times the quantity h plus r. Next is a cone. Very similar to a cylinder, it's 1/3 times pi r squared times h. And then the total surface area is pi times the radius times the quantity, the lateral length, plus r. So L plus r. L stands for the length on this lateral side. Next is a sphere. For the volume, it's 4/3 pi r cubed. Total surface area is 4 times pi r squared. And then for a hemisphere, it's 2/3 pi r cubed for the volume. And for the total surface area, it's 3 times pi r squared. So make sure you go through, write down these formulas, ask any questions in class over any of those variables. Now for an application problem. I recently planted trees in my yard. Some of the trees I planted are Colorado blue spruce trees. There's a picture of one down below. We want to determine what shape could be used to determine the volume of each of these trees I planted, and then we're going to actually find the volume for each of those trees. So the first thing I'm going to do is draw an outline of this tree, make it a little easier to see. Okay, so right now that looks like a triangle, but you have to imagine this is three-dimensional, so that's going to rotate around. So the shape we're actually going to be working with is a cone. Right now we have an equilateral triangle. For the volume for a cone, the volume is equal to 1/3 times pi r squared h. So we need to determine what the radius is and what the height is. The distance across the bottom is 6 feet, and the length across this side is 6 feet as well. So some information we need to determine: this is going to be the diameter, which means we can find the radius. The radius is going to be equal to 3. We still need to find the height, h, which is going to be straight down to the bottom here. So what we're going to have to use is the Pythagorean theorem in order to find h. If we focus on this right side, we have a right triangle. We know the hypotenuse is 6 and one of the legs is 3. So h squared plus 3 squared is equal to 6 squared. Now we can go through and solve. H squared plus 9 is equal to 36. Get h squared by itself. H squared is equal to 36 minus 9 is 27. Take the square root of each side. H is equal to, we can break the square root of 27 down into radical 9 times radical 3, which is going to be equal to 3 radical 3. Going back to the top, our height is 3 radical 3. Now we can take this information, plug it into our formula to estimate what the volume is going to be. So the volume is equal to 1/3 times pi times the radius squared, which is 3, times our height, which is 3 radical 3. If you plug that in, we get approximately 48.97. Our label was feet, and we are talking about volume, so that will be feet cubed. So approximately 48.97 feet cubed would be the volume for each of those trees. Now what you need to do is calculate the volume for a mature blue spruce tree. So the diameter of a mature tree is 20 feet and the height is 50 feet. So for tomorrow, go through, use the formula, calculate what the volume approximately is for a mature blue spruce. In this lesson, we went through some common two-dimensional shapes and the formulas for the areas of those shapes. We also went through three-dimensional shapes and the formulas for volume as well as surface area for all of those. All right, now we're going to use those more in class. Given an application problem, determine what shape we can use to estimate either the volume or the area depending on what we're talking about.